Hello students, welcome back to video number 11. This is the last video of third chapter, that is motion straight line. I wish all the students must go through the first previous videos, first 10 videos before going ahead with this part. And in this we straight away enter into the concept of relative velocity. What is the meaning of relative velocity? The meaning of relative velocity is understanding the velocity of an object with respect to certain conditions. What are the conditions? You may observe an object in motion by placing yourself in rest position or by placing yourself also in motion. Accordingly, the velocity of the object appears to be different. Relative velocity says that velocity of an object appears to be different for different kinds of observations. Observation is the things what you are doing. If you make yourself at rest position and observe, you will get some velocity of the object. If you move along with that object, you will get some kind of velocity. If you move opposite to the object, again you are going to get some kind of velocity. So according to this mechanism of understanding one velocity with respect to the other is called as relative velocity. To understand this concept of relative velocity, first of all, you should have the knowledge on this part called as frame of reference. Because a frame of reference is the one usually where observer is present. You are observing something. Some event is taking place, like the motion of an object. To observe that, you are observing something and you are the observer here. And where the observer is present, there we imagine the coordinate axis. From some distance from you, the event is taking place. Now this is at this location we now make use of. Now you are here, you are observing something which is taking place some distance away from you. How long is that? How much is that distance? That means from your point of view, this is the thing what is taking place. Accordingly, observer, where the observer is present, at that point we now imagine the coordinate axis. That imaginary coordinate axis is called as a frame of reference. This frame of reference can be at rest or can be in motion. What does it mean? Observer can watch a thing either by placing himself in rest position or he can watch that by also making himself in motion. Accordingly, moving observer or rest observer. Moving observer corresponds to moving frame of reference. Rest observer corresponds to rest frame of reference. Now, what is that we are trying to say in this concept of relative velocity with the help? Now, if we have this knowledge of frame of reference, what are we trying to say? I'll take an example to make you understand this easily. Example. Consider you are person B standing on the platform and your friend is moving in a train in this direction. If you are standing on the platform and your friend is in train that is going in one direction. Now, as the train departs, what is it you are going to find? You will find that your friend appears to go in one direction and you will be at that. Let us suppose your velocity is at rest, so you are in moving, and your friend will be having that velocity same as the velocity of the train. If whatever the velocity train has, that velocity is acquired by the person inside the train. Accordingly, person's velocity is going to be VA. When you are standing and observing this, you will find its velocity to be something. If you also move along the direction, you will find this velocity to be different, not the same. And according with respect to you, how much is your friend's velocity? And that would usually take place in one direction. Going in right side direction, we call it as positive. Your friend is going in forward direction or straight direction, that is positive. Now from your friend's point of view, from A point of view, B would be appearing to move in this direction. You can understand this easily. If you are going by train or car or bike or bus, anything, you will find that things outside your bus will be going in opposite direction to us. If you are going in one direction, things would go in the opposite direction. Means if one is considered as positive, other is considered to be what? Negative. Now, if you stand and observe, you will find some velocity. If you move in the direction, you will find some velocity. If you go in the opposite direction, you are going to get some velocity. Understanding these things is what we call it as the relative velocity of A with respect to B, or relative velocity of B with respect to A. Let us suppose one person is moving and observing the train, one is at rest observing the train. Now both of them appears that case to be same velocity. It differs accordingly. We say relative velocity of A with respect to B or relative velocity of A with respect to C. Now let us try to understand the graphical way how we show these things. Graphical method of understanding these relative velocities. What we do is that using this method, we now try to identify the change in position. We are now going to get mathematical derivation, mathematical form of relative velocity of two things. For that, what we do is that we take two objects A and B moving with velocities VA and VB. Consider two objects moving with velocities VA and VB, and these velocities are uniform. Object A is also moving with constant velocity. Object B is also moving with constant velocity. Magnitudes may be different, but throughout the motion they are maintaining the same constant velocities. Now what is that we are going to show? We show for object A like this. For object A, let us suppose that it is the time axis, it is x axis. Let object A is initially located at 0A. x0, A is the initial position of object A at a time of t is equals to 0. Object A is here. It is now traveling with some uniform velocity. Uniform velocity gives us to what kind of a graph? It is now going to give us to a graph given by means of a slope like this. What does this slope now indicates? If you draw the line, this indicates the change of time, and during that change of time, this indicates the change of position. Change of position is this one in a change of time given by means of this. The ratios of these two is what we call it as velocity, because velocity of A is VA. It is been now shown by means of VA. Now what is the final position of x now? Let us suppose final position of x is equals to XA. This is for object A. Now let us write for object B. Two objects are moving from their locations at same time of t is equal to 0. Both of them, one is having its velocity variation like this, another one is also having its variation taking place like this. Initial position is what? X naught b. And for how much of time it is traveling? It is also traveling for the same time. It is also traveling for the same time. During the same time interval, both of them are starting at same time t is equals to 0, and both of them are traveling with constant velocities VA and VB. We now wish to find the change of positions of one with respect to the other. Change of positions and how these relative velocities are related. Now what is the final position of B now? If you take this as x axis, now this is the line what you draw. This now corresponds to change of time interval, and this now corresponds to what? Final position, or this is delta x. Final position can be now given by means of what? Xb. Is that clear? We are starting for A at initial position x naught A, traveling for a time of t, reaching the final position xa. This change of position is taking a time of change of time delta t. Accordingly, final position is appearing here. This line indicates velocity because this has got both magnitudes with that. Ratios of y by x gives rise to velocity of A, velocity of B. Now, how to write equations for these two? Let us write equation. Final position of A is given by XA. How can you write this final position of A? Final position of A is equals to this location plus this location. Initially position is here, finally it has gone there. How much is the total final position now? Total final position is equals to initial position plus, can I write it as VA into T? Position is equals to velocity into time, right? VA into T. Equation number 1 this is. Final position of A is given by means of XA is equals to x naught A plus VT. Similarly, what can you write for final position of B? You can now answer this. Final position of B is equals to, we indicate that by XB is equals to x naught B plus VB times of T, because in a time of T it travels a distance given by means of VB into T. Both are traveling for same time T. Accordingly, covering some distance, but both velocities are different. Accordingly, the displacement covers is going to be how much is the change of position. Therefore, change of position from A to B, let us say, that is XA minus XB. How much is the change of position from X position XA to XB? A to B. We can write for B to A also. change of position from xa to xb. If you take this as equation number 2, xa minus xb can be written by means of what? RHS minus x naught a plus VAT minus x naught b minus VBT. This is x naught a minus x naught b is one term. Change of position is difference of these two positions. X naught a minus x naught b plus VA of t minus VB of t. That is xa minus xb is equals to. That is xa minus xb is equals to x naught a minus x naught b plus times of VA minus VB multiplied by t, because time is constant. Now this factor VA minus VB, this factor VA minus VB is called as relative velocity of A, relative velocity of A, we write it like this, relative velocity of A with respect to B. What is that? VA minus VB called as? VA minus VB is called as relative velocity of A with respect to B, and this is denoted by VAB. What is called as? VA minus VB term is called as relative velocity of A with respect to B and denoted by VAB, which is equals to VA minus VB. You can put vector, because velocity is a vector, you can put lines like this, vector or bar like this. That is, this is one of the important term, that term of VA minus VB. I'll just remove this part. That term of VA minus VB is called as relative velocity of A with respect to B. Change of positions is corresponding to velocity positions or velocity difference in terms. That is, I'll write like this. VAB is equals to I'm writing that last step here. VA minus VB. What is this one? What is this equation called as? This equation is called as relative velocity of A, velocity of associated with velocity associated with A as seen from B. What is that? VAB means velocity associated with A as seen from B is equals to VA minus VB. Similarly, what is that you can write for VB minus VA? Velocity associated with B as seen from A is given by VB minus VA. These are the formulas for relative velocities. Relative velocity means comparison of one velocity with respect to the other, or understanding the magnitude of velocity from different kinds of observations. Accordingly, these are the two formulas what you should remember, and I'll give you some kind of different ways to understand this. That is, velocity of A with respect to B is given by velocity of A minus velocity of B. Velocity of B with respect to A. Clearly, can you now say that velocity of B would be equals to minus of velocity of B to A? What is the meaning of velocity of A to B is minus of velocity B to A? Both are traveling. If both are traveling in opposite directions. Just now you have seen this. What is that? If you are traveling in a car in this direction, any other person who is outside us will find to be traveling in opposite direction. If you have velocity of VA like this, you will find that other person will be having velocity, will be going in opposite directions. Both are same in magnitudes and traveling in opposite directions if other person is at rest position. It means it is something like this. Let us suppose you are in a train and your friend is in platform. Your friend is at rest position in platform and you are moving with some speed VA. Now with respect to your friend, you will be having same velocity as it is the velocity given by the train. Velocity of u with respect to your friend would be positive some value. Now in the same form, what is your friend's velocity as seen from you? Velocity of B, it is now going to be the same value, but in what direction? It is now going to be in the form of opposite direction. Accordingly, this is a mathematical formula of relative velocity. Velocity of A with respect to B is difference of those two velocities. I'll just pause a while. Right. Let me now show you the graphical representation how to indicate this relative velocities. Relative velocity means minimum there should be two velocities to compare. Relative comparison of one with respect to other. You cannot say one as relative. There should be minimum two things, or out of three, what is out of four you can say relatively this is big, relatively this is small. Now relative to this is smaller. Relative to this is bigger. Accordingly, that is the mean comparison of one with respect to other. You can say what is the meaning of relative concepts. I wish to now show different kinds of representations of two bodies having various velocities. Now, what is the first case? First case is that consider an object A moving with velocity VA same velocity as that of object B. There are two objects A and B moving with same velocities and starts at same time and having different positions. Means, let me say this is time, this is x, this is v, and this is v naught b initial position, or this is x naught b, sorry, initial position, and this is x naught a. Two objects A and B, this is A and this is B. Two objects A and B are having same velocities. What does it mean? But starting at different locations. If both start at same time, one will overlap with each other. Accordingly, its velocity should be same. Accordingly, you are going to get parallel lines. Now, what these parallel lines indicate? Parallel lines means having same slope, right? Parallel lines means having same slope. Having same slope means what? Slope is equal to y coordinate by x coordinate, x by t, that is position change by time change, gives rise to speed or velocity. Accordingly, if both objects have same velocities, then those velocities in the form of xt graph can be shown by means of set of parallel lines. Speed is, now how much steepness we are showing here, that is also important. If there is less, let me suppose this is some 40 meters per kilometers per hour, this is also 40 kilometers per hour. This is a steepness. If I say 30 now, if I say 30 kilometers per hour, it is now going to be down. It is also going to be parallel to that down. If I say 60, steeper. More steeper the line is. This slanting position is called as steepness. If it is more steeper, more velocity. Less steeper, less velocity. Why it is more steeper, more velocity? Because in less time, more steeper means it is covering larger displacement or larger change of position. Less steeper, more time. Here is a less steeper. Change of position is only this much. Hopefully you are able to understand this. Or the steepness indicates the speed or velocity of the body. Lesser is the steepness, less is the velocity. More is the steepness, more is the velocity. For any kind of a graph like this, if we get straight line, let us suppose parallel to time, no speed, it is at rest position. Not rest position, slight speed is there, then slowly it increases. Larger speed is there, highly it increases. Accordingly, you should get this difference. You should get that difference. This is velocity of B, same as that of velocity. If one more body with same velocity, there is one more body called as C having same speed as that of this to starting at same time. If it is having more than A, if it is having more than B, it would be here. Less than A, it would be here. In between those two, somewhere here. I think you should be much careful in understanding things. If you are indicating two kind of parallel lines for velocities like this, it means that you are talking about having same speeds with that. Start at different locations but traveling with the same velocity. Now, how can you show a graph for this case now? Velocity of A should be greater than velocity of B. Again, this is position only. Let us suppose this is initial position of x naught A, this is initial position of x naught B. Both are there. Whose speed is more here? Velocity of A is more. So it has to be more steeper. Velocity of B is going to be less steeper. This is the way how we show this. Now, is this point clear? This is having more velocity than this velocity. Why this is having more velocity? If you check for the given time, this is the time taken. If I draw a line like this, this is the time taken. This time, it is the given time. This is undergoing a larger change of position, whereas at the same time, it is undergoing only small change of position. Displacement by time, this value is less, this value is going to be more. This is the way. Now we can say that this is velocity A, this is velocity B. Now there is some kind of a thing present here, intersecting lines. What does it mean? Do they mean that both vehicles are colliding, both objects are colliding with each other? No, it is something like this. You are two persons, one is starting on bike, another is starting on cycle. Both are traveling to same destination. Both are starting at same time. But what happens? A person who is going on bike will cover larger displacements in shorter time, whereas the person going in cycle will cover that distance in less time. Sorry, more time. Is the point clear? Accordingly, this you can understand this by taking the example that this is a person B is traveling on cycle, a person A is traveling on on bike. Accordingly, both are having different speeds. Now, what does this point line indicates? Indicate that overtaking, where these two people are overtaking each other. After traveling of some distance, one has to overtake because first person is going at a higher speed, second person is going at a lower speed. I am going on cycle at lower speed, some other person is coming behind me, both of them are starting at same location or let us say different locations, but what happens, usually the person with higher speed overtakes the second person. This intersect line indicates what, at what time, at what location these people are overtaking with each other. Now how to show this third kind of a graph? X and T, again initial position of XOB and initial position of XOA. Now what is that? VA is lesser than VB, means it will now go like this and it is now going to go like this. VA less than VB. Not intersecting, both are starting at same location, but person B is going at high speed, so velocity of within the given time is covering larger displacement and velocity is more. So these are not intersecting. If you are showing some kind of parallel lines, both are traveling with same speeds. If one speed is more, other speed is less, the one with more speed will be having more steepness. The one with less speed will be having lesser steepness. Now in this case, we are showing that VA is less than VB. Velocity of this is VB. And this is going to be VA. It is all some simple logical things. It all depends on how we take the things. So this kind of graphical representation can be done for relative loss. Comparison of A with respect to B, A with respect to B, which is having more velocity. The moment they are hitting, it does not mean that they are colliding. It is a point of what? Overtaking. Like where exactly these people are overtaking each other can be identified by using this kind of the intersecting line. Let me take one quick example to understand how to calculate relative velocities. Now look at this example to understand this concept of relative velocity problems based on relative velocity. In one way it is simple only thing is that you should apply that formula VA minus VB. Problem 1 it is. Look at the question now. If train A moves with 60 km/h in one direction and train B moves with 40 km/h in opposite direction, find relative velocity of A with respect to B and relative velocity of B with respect to A. Analyze the question and first get the concept. Train A is going in one direction, obviously not on the same platform, opposite different platforms, right? This is a practical experience for us. When we go in one train, we get some trains passing by behind other tracks, right? This is a general experience what we get. There are two such trains moving in opposite directions on different tracks. Make sure that it is different tracks, right? Right. It is in the form of one is having 60 kilometers, other is having 40 kilometers. Now you need to find velocity of one with respect to other. This is one of the simplest or practical case what you can understand. Once we get the answer, I'll let you know what this practical experience we are going to get. Let us first say train A is going in this direction in the form of what? 60 km/h, and train B is going in opposite direction in the form of what? 40 km/h. Now use sign convention properly because plus and minus is equally important in terms of vectors. Whenever you come across vectors, velocity, plus and minus is equally important. Accordingly, towards right let us consider plus, and it is towards left it is considered as negative. Now what is the first part you need to do? Relative velocity of A with respect to B. Relative velocity of A with respect to B, write like this. Relative velocity of A with respect to B is equals to, formula is VA minus VB. What is VA? 60 minus, by formula it is minus, and for B, because it of opposite it is going to get one more minus, which is equals to 100 km/h. What is this velocity of A with respect to B? 100 km/h. Velocity of person in train A as seen from B. You are watching velocity of person in train A. The person who is watching from train B finds that person in train A going with 100 kmph. Actually, train A person is going with 60 kmph only. But because of relative mechanisms of opposite directions, what is happening? Person in this train is appearing to be 100 kmph for this person. Similarly, let us check second part now. VBA is equals to VB minus VA is equals to minus 40 minus 60 is equals to minus 100 kmph. Now what is this? What is minus 100 kmph? What is this plus 100 kmph? BA is minus 100 kmph. What does it mean? Person in train B appearing to be 100 kmph for a person. Person from train 1 is watching a person in train B. Both of them are appearing to be, means person in train A feels that the other person going at 100. Person in train A going at 60. He finds that person in train B going at 100. But in fact, at what speed the person in train B? Person in train B is actually going at a speed 40, which is 20 less than his speed. But still the person of train A finds that other person is going at high speed than his speed. Actually, the person in train B is going at lesser speed than train A, but he feels that the other person is going at 100 speed. And this is a general thing what we see. Every time we always feel that other train is always going at a faster rate. When we are moving in the train, we always find that the other train goes faster than our train. Yes or no? We find that the other train which is passing by, which is coming in the opposite direction from us, will find that he is actually going at lesser speed than us, but we feel that he is going at 100 km. Similarly, the person in train B also feels that he is going at, person in train B is actually going at 40. He feels that we are going at high speed. No doubt we are going at higher speed than the other person, but we are going at very much higher, and this negative sign indicates that both are going opposites to each other. It is a simple thing. Or remember like this. Relative velocities of two objects going in opposite directions is sum of velocities. Relative velocities of two objects going in opposite directions is sum of velocities, and it is positive for right side direction and it is negative for leftward direction. Now let us check the second part of this one. What if both the trains are moving in same direction? I'll just erase this part and I'll solve it here. If both the trains are moving in same direction, solution 2, I have to remove this and I have to keep this also plus, right? Both are moving in same direction because both are towards right or towards left, it is right. VAB is equals to VA minus VB is equals to how much? 60 minus 40 is equals to 20 kmph. VAB. Then VBA is equals to what? VB minus VA, which is equals to 40 minus 60 is equals to minus 20 kmph. What does it mean? Because one is at higher speed, second is at lower speed, the one which overtakes the other will appear as the other one to be going at opposite directions. Because train A is having higher speed, this overtakes this. When this is overtaking this speed, what is that speed he is going to find this train to be? Its speed is going to be found to be how much? The person in train A finds that he is going in back while overtaking. He will find that this is going in backward direction because it overtakes. And at what speed is overtaking now? It is now overtaking at a speed of what? That person in train B appears to going in backward at a speed of what? 20 kmph. Minus indicate that they are traveling in the opposite directions. Now what happens? Third case. Case 3 I will take. Now what happens if both of them are having same velocities? What if VA is equals to VB? What if VA is equals to, if both the trains are moving in same direction, same velocities. Both the trains, I'll just write in the upper part, case 3. Case 3. If velocity of A is equals to velocity of both the trains. You can imagine this situation. You can imagine this context. What is that? Suppose that both the trains are starting at the same location and moving in the same direction, same speed. Obviously what happens, one appears, others to be at rest. Both are starting at same time, same location and moving in the same direction. At every time one appears to be other. Both the friends from both the trains are seeing each other. After some time they appear to each other. Again after some time they appear to be each other. Accordingly, if VA is equals to VB, then VAB is equals to VA minus VB, because both are same, it is equals to what? 0 meters per second. Means one appears to one. Both are moving. Relatively what happens? VA is appears to be at rest for VB and vice versa. If both, remember like this, if both trains are moving in same direction, then relative velocity is equals to difference of velocities. If both velocities are moving in opposite directions, then the relative velocity is equals to sum of the velocities. Opposite directions is sum of velocities, same direction it is a difference of velocities. No matter whatever the same or opposite direction, general practical experience is that if they are moving in same direction, you are going to get difference of velocities. If they are moving in opposite directions, you are going to get the sum of velocities. So this is end of my sessions. Along with this, I'll just conclude that we noticed that most of the students are feeling burdened to listen to video lectures because of size or availability of time and all when waiting for offline classes. Even we are also waiting for offline classes, let's hope. But no matter when the university opens or not, a point on to students is to note is that they should always focus on the videos what have been presented to you. Different faculties will come and teach different chapters of physics. No matter whoever the faculty is, all the faculties may not teach in the same form. You try to accustom with one particular faculty in one form. All faculties will differ, their teaching methodology will be different, but your responsibility is to say you are making yourself free in understanding them. Thanks for joining me for this chapter. Hopefully see you soon. Stay safe, stay happy. Good luck for your future. Thank you.